Welcome! In this exercise, we will calculate the circumference of the circle of radius r as the limit as n approaches plus infinity of the perimeter of the regular n-gon of radius r. The regular n-gon is the regular polygon with n sides. Let's consider the general regular polygon. We will denote by S the side length, by alpha the central angle, and by r the length of the radius. With this notation, the perimeter of the polygon is given by the number of sides that multiplies the length of each side. Moreover, the central angle is equal to 2 pi divided by n. Here we have drawn the polygon and the apothegm. Then this will be half of the central angle. This will be alpha over 2. And this is 1/2 of the side, s over 2. Since this is a right triangle, then we can immediately write that s over 2 is equal to the radius r that multiplies sine of alpha over 2. Thus, S, the side, is equal to 2 times the radius times sine of alpha over 2. After making the substitution of the value of alpha, we obtain the expression for the side of the polygon. The side is equal to 2 times the radius that multiplies sine of pi over n. Then, by using this expression for the perimeter of the regular n-gon, we obtain that the perimeter is equal to 2 times the radius that multiplies n times the sine of pi over n. Finally, we have to calculate the limit as n approaches plus infinity of the perimeter, Pn. This is the limit as n approaches plus infinity of 2 times the radius times n times sine of pi over n. After dividing and multiplying by pi, we obtain that this is equal to the limit as n approaches plus infinity of 2 pi r that multiplies n over pi times sine of pi over n, which is equal to the limit as n approaches plus infinity of 2 pi r times sine of pi over n divided by pi over n. This factor is independent of n. Then this is equal to the limit as n approaches plus infinity of sine of pi over n divided by pi over n, and this limit multiplies 2 times pi times r. Note that the limit as n approaches plus infinity of pi over n is equal to 0. Then, by using the rule of the limit of a composite function, we obtain that the limit as n approaches plus infinity of the sine of pi over n divided by pi over n is equal to the limit as x approaches the limit as n approaches plus infinity of pi over n of the sine of x over x. And this is equal to the limit as x approaches 0 of sine of x over x. And this limit is 1. Then the limit as n approaches plus infinity of the perimeters of the regular n-gons is 1 times 2 pi r, which indeed completes the exercise.